Good morning everybody and welcome to another webcast from Innova Systems. Today we're going to look at a new SolidWorks product called SolidWorks Plastics. Now this is available in two versions and today we're going to be looking at the professional version. So before I take a look at SolidWorks, we'll take a look at what the SolidWorks Plastics Professional actually does and who it's for. So this is really geared towards part designers, plastic parts designers, and it sort of helps people answer the basic questions. So will the part actually fill? Where are the weld lines? Will there be any air traps? It also simulates the mould filling stage and helps designers optimize the part for manufacturing. We can also look at positioning the gates in the best locations as well. So weld lines and air traps are very important. You may not be aware of where they are when you're actually designing the part, so we can use plastics to take a look at where they will be. Okay, so I'll switch over to SolidWorks now and we'll take a look at the software in action. So you'll all be familiar with the SolidWorks interface, and I've got a plastic component on the screen here at the moment. Now plastics is an add-in, so we just control whether or not it's on using the add-in tools. You can see mine's on here already. So once that's turned on, you actually get an additional toolbar along the top here, and we also get another tab on the Feature Manager design tree as well. So if we go over to the Plastics Manager here, we'll take a look at a pre-set up study that I've got here. So as with most simulations, the first thing we need to do is actually mesh the part, and you'll see we've got a section along the top here to mesh. There's two types of meshing in SolidWorks Plastics. One is a solid mesh, which will completely mesh the whole part, very much like a solid mesh in standard simulation in SolidWorks. The next one down is a shell mesh, and this does differ from a shell mesh in SolidWorks simulation. So a shell mesh in SolidWorks Plastics will actually mesh all the external surfaces rather than taking a mid-plane like SolidWorks simulation does. So that just enables the studies to run a little bit faster. There's some automatic settings on the mesher here and also some manual ones, so if you want a more refined calculation, we can actually set the triangle size and look at the resolution of the mesh, which is really good. In the higher level product, SolidWorks Plastics Premium, we can actually specify mesh controls in certain areas. So for example, around a gate location you may want to specify a higher resolution mesh, or on certain small features. Within the professional version that we're looking at the moment, we don't get any mesh control functionality at all. We just get the ability to mesh with a particular triangle size. So working from the top down in terms of setup, once the mesh is complete, we then move on to the input section, which allows us to choose a material that we're actually going to be using. So this is a completely separate database from the SolidWorks database of materials, and if we open this up here, you'll see that it's quite a comprehensive database of plastic materials. So if we take a look here, you'll see we've got materials like ABS, you can PP, for example, polypropylenes down here, and various different grades within that as well. So if you are in the sort of plastic arena, if you like, you'll probably recognise some of the names here. Now these materials in this database store the information that's required for plastics to run the simulation, including melt temperature, the recommended mould temperature, things like that, the viscosity values which are used to calculate the flow, things like that. We've got a few nice facilities within here, so we can sort via the company, so you can actually look down here. So if we look, you've got BASF and other plastics manufacturers here, or alternatively we can sort them by the family that they fit into. We also have the ability to search the database as well, so for typing in a particular grade of plastics we can use the find tool there. So once you've specified your plastic, we want to choose a PP, so we'll just go down here to the PP section, and we want to choose, well, let's let's double check which one we want to choose. We want to choose a Novaline 1100H, so we'll find that, which is here. So we can select that and say OK. You'll see on the left-hand side, once we complete certain elements of the setup, that a little green tick appears over the section to let us know that we've actually done that. So the next stage for me really is to move on to the machine section here. So this allows us to select a machine that we're going to use for the actual injection moulding. Now, in the professional version of SolidWorks Plastics, we only get the choice of the default machine, so small, medium and large. And if we look at those, the information that's stored within these machines is the injection pressure. So for small components you would use a small machine, medium and then large, and you'll see the difference in the injection pressure shown there. In the premium version of the product we actually get a much larger database of machines and manufacturers. So, you know, the premium side of the software is more geared towards mould tool designers than it is plastic part designers. So that would allow them to select the specific machine that they're using. So we're going to choose the small machine here and say OK, and again the green tick appears over the top of the machine. Now just below the machine section is the process section, which includes the flow settings. Now these can be calculated automatically. You'll see there's an automatic button here, and the system actually uses some equations based on the mass of the part and the material properties to calculate the estimated filling time. Now if you do want to override those values, you can do. We can just toggle off the automatic setting and actually fill in a filling time if you need to. You'll see the melt temperature for the material is pulled up, and also the mould temperature, or the recommended mould temperature as well. Again, in the premium version we get some additional options here in terms of specifying a heating graph for the mould, so you can say that it starts off at room temperature and works up to its recommended final temperature, for example. Okay, so once those flow settings are done, the next little bit for us to do is to position the gate where we want to gate this particular example. Now gate selection can be quite important on parts that, you know, have nice surface finishes. Ideally we want the gate to be on the inside because they leave a little bit of a sprue left over. So, you know, if you want to be in control of that gate location, you can be. We can use the automatic settings again within here, so we can automatically place a number of gates if we want to, or alternatively we can just pick somewhere on the model and position a gate where we want it to go, and then just click the Add Gate button. That will then add the gate. You know, if you're more interested in the gate locations and runner design in the premium product, we can actually model the runner design and include that in our analysis if we need to. So that can be quite good, and it also includes things like runner balancing as well. We'll take a look at the differences in the products in a moment on a PowerPoint slide that I've got while the study's running. So once the gate location is added, we can just say OK, and then we can move on to actually running the study. So you'll see that it's very quick and easy to set the system up. It doesn't take too long at all. So here, if we run this, I'll just say yes to that because I've already run one of these before, and we'll just move that window out of the way and we'll let that run through. So as I say, we're going to take a look now at the differences between the two versions. So we'll just minimize that there and we'll take a look. So currently we're looking at Plastics Professional. I will be doing a recorded session on Plastics Premium at a later date, which we'll publish to the website. So we'll try and include a link to that in the email that goes out, but keep an eye on the website for that to come up as well. So within Plastics Professional we can do surfaces and solid meshing, as I've mentioned before. We don't get the ability to control the mesh with refinement levels and mesh controls, though. That is in the premium package. We can also do filling analysis, predicting short shots as well, so if the mould isn't actually going to fill with the settings that you've set. We can show weld lines, which we'll look at in a moment, air traps as well, and we can also include multiple gates. So that's the Plastics Professional, and we'll take a look at those when the study's finished. In the premium package, we can also do multi-cavity moulds, so family moulds if required. We can do runner balancing studies, so if you have two components that you're moulding together that are different volumes, we can actually create a runner balancing study to adjust the size of the runners to equal the filling time. We can also look at cooling time of the mould or of the moulded component. We can also look at the shrinkage values and sink marks. We can do over moulding as well. There's also some options on gas assist moulding and valve gating, and also co-injection from multiple materials. Another nice option as well, if you are using sort of glass-filled plastics, we can do a fibre analysis as well to predict in which direction the fibres are going to lay after moulding, so that can be really important for strength. Okay, so I'll switch back to SolidWorks now, and hopefully we'll see, looks like it's still running here, but we can have a look at the partial results, which is really what we want to have a look at here. So what I want to do is just play this animation of the fill time just to show you what's occurring. So if I actually just stop this and move this bar back, we can take a look at certain areas of the filling. So one of the things that I want to point out here is on this particular example, you can see that the plastic flow is sort of moving very quickly around this boss here. What actually happens is the plastic sort of gets in front of the main flow front and causes an air trap. And that's not really very good for this particular component. We want to try and sort of move the air traps to the top of here. It's something that's called race tracking, and it occurs really when a uniform plastic flow sort of hits large sections, so thicker sections, and it flows through there faster than it does the thinner sections. So this can cause air traps and weld lines where the flow fronts meet, and we want to try and reduce that as much as we can. So if I just come out of the flow results here and switch back to SolidWorks, we can see that the system is very, we'll just turn that cavity visibility back on. It's very integral to SolidWorks. We can switch between the model and the simulation very, very quickly, just the same as we can with SolidWorks simulation. And what I want to do here is use a tool on the Evaluate toolbar called Thickness Analysis, just to highlight thick areas of the design that I may need to change to try and move those air traps to the top of the boss. So this is available on the Evaluate toolbar. We can fill in some parameters here just to get it to highlight thick regions. We can also use the measure tool to understand what the general wall thickness of the part is as well if we want to, which is actually 1.27 millimeters. So I've set it to show me the thick regions above that wall thickness, and then we can use the calculate button here to actually calculate where those thick regions are. If you've modelled the component yourself, you may know where the thick regions are, but you know, this is quite a nice way just to highlight those areas. So we can see that we've got a thick boss here which is around the region we were seeing the problem. So what we can do, excuse me, is I'm actually going to open another part which has got a revised change to that just to try and speed things up a little bit, and we can look at the differences in the results once we've altered that thickness. So if I go over to my modified version, you'll see we've just made that a lot thinner, more in line with the wall thickness of the component. And if I just run through the setup again on this component, we can take a look at the results again. So we'll just specify the material, the machine, the flow settings are automatic, and we'll just position the gate again here, which needs to be here, and we'll just add that. And then what we can do is we'll just run that again, and we'll take a look at the area we were referring to earlier, just to see the differences that a thickness change makes. So we'll just let that run through. You can actually leave this window open or toggle off the display of partial results, but what we're doing here, we ideally do want to look at the partial results here just to get an understanding before we complete the whole flow analysis. So we can see we get a running information in terms of the injection pressure required to fill the mould, so the amount of pressure that's forcing the plastic in, which can be quite useful. You don't want an overly high pressure. But we can see straight away here that the flow front is actually remaining reasonably constant through that boss now. So the change in thickness that we've made is going to cause the air trap to move to the top of that boss rather than sitting down the bottom. And air traps, or sort of removing air traps or moving them to areas that can be vented, can be quite useful because the air is under compression in the mould and it can explode, causing burn marks and blackened surfaces on the components. So the more you can do to sort of move those air traps to the top or areas that can be vented, the better, really. Okay, so we'll just let that run a little bit further. You can see some of the other results that we can get out of the system as well. So not only do we get a fill time, but we will also get things like the pressure at the end of the fill, the temperature, the shear stress, cooling time, and also the gate filling contributions and how easy the mould is to fill. So, I mean, these can be useful plots for you to understand exactly what's going on with the component, and we'll take a look at some of those when this is completed. We also have the ability to record the animations as well, which is quite nice. So if you want to show people that you've actually done these type of studies beforehand, you can do. But it also just allows you to get more of an understanding of what's actually occurring with that part during moulding. You can play the partial results as well during the study if you need to. So, you know, we were looking at trying to reduce that that sort of air trap as much as possible, so we don't necessarily need the whole study to run. But if we want to take a look at some of the other graphs, we would need to just allow that to finish. So if I just refer back to our slide here, we'll look at the next one in terms of the summary of what can be done with plastics. So, you know, from a designer's perspective, it allows us to predict and avoid injection moulding manufacturing defects at an early stage. We can eliminate mould rework. We can also improve the part quality, and we can decrease the time to market. Ideally, the changes to part design should come from the designer, but I'm sure a lot of you have found that once you send the part off to a moulder, he will come back and ask you to make changes, and that can be a lengthy process if you're under time constraints. So the more you can do, you know, before it goes off to the moulder, the better. So let's just switch back to SolidWorks now, and we'll take another look. Okay, so that looks like it's completed there. We'll just take a look at the full fill time plot here. So you can see that the mould completely fills in the specified time, and we also get an understanding of how long that's going to take to fill. We can see it's 1.35 seconds there. Now, one of the things that I want to turn on is the air traps. So we can see that our air trap is now at the top of that boss where we suspected it would be after the change, and we've also got a few others towards the bottom here as well, but the majority of them are on a sort of parting line, if you like, which means they can be vented quite easily. Another useful plot that we have is the weld lines. So weld lines actually occur when the flow front merges back together after going around an obstacle like these holes here in this particular component. So we can turn that on and we can see where these weld lines occur. Now, you can't necessarily get rid of weld lines completely, but what we can do is sort of move their location to areas that aren't under high stress, for example. So if you are doing a component that is subjected to loads, you may not want weld lines in areas of high loading. So depending on your gate location, you can actually move those weld lines around the component, and it'll just allow you to maintain strength within the part. So, you know, this can be a very useful plot for understanding where they will occur. We can also show the pressure at the end of the fill. So, as I mentioned, when we choose the machine, The machines have a limited injection pressure that they can use, and we can see here that our pressure required to fill this component is under the maximum of 80 for the machine we chose. You'll also see over on the right hand side, hopefully if you've got the GoToMeeting sort of window minimized, that SolidWorks Plastics includes a results advisor which will actually describe to us what the plots mean, and this can be very useful when you're sort of getting into this from an early stage. It will explain to us what the graphs are showing and what implications the results of those graphs actually have. So that can be a useful addition there. Another one that's quite good is the shear stress at the end of fill. So as long as that occurs below the sort of graph that's shown here, then we shouldn't have too many problems. But if you do want to look at sort of moulded in stress and whether warpage is going to be occurring, this can be a good indication of whether that's going to happen. The final one I want to talk about is the cooling time. Now this is an estimated cooling time for the actual mould as well. This can be important for the overall cycle times of your components, how long they're actually going to be in, how long they need to stay in the mould, and how long the overall cycle time is going to be. Now the premium version of SolidWorks Plastics will actually give you a complete cycle time in addition to some other options which can be useful for moulders. So for example, we can get X, Y and Z plots of the clamping pressure required to hold the mould together. Again, you know, that can be useful for these guys. But from a designer's perspective, we may want to understand if certain areas are going to take longer to cool. Sorry, you'll see here this large boss at this end is going to take a lot longer than the majority of the other part to cool, which may mean that we get a higher shrinkage in terms of a percentage in that area. So we may also need to reduce the wall thickness in that area. Okay, so that sort of gives us a good overview. If we take a look at, I'm just going to close this window here. If we take a look at another component which I've got here, and I'm just going to read the results in for this particular item. So this is a thin-walled cup that we might want to make, and if we go over to SolidWorks, and let's just come out of that. If we go over to SolidWorks here, we can take a look at the wall thickness and see that it's 0.6 thick. Okay, so quite a thin-walled part. If we read the pre-run results that I've got here, what we can see is that we actually get what's called a short shot occurring. So the maximum pressure of the machine has been reached, but the mould hasn't completely filled. And this can occur when you have very, very thin-walled components, just because you require a higher pressure to actually completely fill the mould. So really from a part designer's perspective here, we can see that a 0.6 wall thickness isn't really very good. So ideally what we would want to do is either specify a higher pressure machine, which still may not solve the problem, or alternatively we can go back to SolidWorks and make a modification to the wall thickness. So we could change that to 0.9 for example, just increase that wall thickness a little bit, and then we could rerun the study and take a look and see whether or not we got, you know, a completely filled mould. So these changes can be done on the fly. You can see very quickly that we can switch between SolidWorks, the main sort of area, and SolidWorks Plastics as well. So the two are very integrated together. If we just we'll just go back to the PowerPoint slide here, and we'll take a look back at the capabilities of the two softwares. So we've taken a look at the filling analysis, a brief look at the short shots and what we can do to make those better. We've also displayed the weld lines on a particular component and looked at the air traps. We didn't look at multiple gates, but again that's just a question of adding multiple gates to the design. So what I want to talk about just to finish off here is some of the things that Plastics Premium includes that Plastics Professional does not. So in Premium we get the ability to run a fill and pack analysis. So what the pack analysis will give us is a total run time for the component, how long it actually needs to sit in the mould, how long it's going to take to cool, which will give mould designers an idea of the cycle time. We also get, as I mentioned previously, the ability to refine the mesh in certain areas, things like that, which is very good. A larger collection, a larger database of machines as well. Okay, so that sort of brings us to a close. As I say, I would keep an eye on the website for the Plastics Premium recording, which I will be doing probably next week, I would imagine, just to give you an idea of the differences between the two systems. But thank you very much for watching this short webinar on SolidWorks Plastics. It will be recorded and available through our website. And please also take a look at the future webinars as well, listed on the screen. And I'm going to leave that slide up for the time being, and then I'll just double check and see if anybody's got any questions which I can answer. I can't see any at the moment, but if anybody does want to watch, sort of ask any questions, then please do. There should be a little window on your GoToMeeting toolbar there. So I'll just hold on and see if there's any appearing. So we've got a question here about whether it covers extrusions. Not really, no, because it does. I'm not sure whether extrusions, they're sort of a plastic forced through a moulding, so it's slightly different. I don't think it does cover extrusions. But what I'll do is I'll double check and make sure. I'll jot that down, Dominic, and I'll find out for you. But I suspect that it doesn't. Okay, any other questions? Okay, just bear with me here. I just need to scroll up a little bit. So somebody's asked whether or not MatWeb data can be added to the materials library. Within SolidWorks Professional, it doesn't have the ability to add custom materials to the database, but in SolidWorks Premium we do have the ability to add custom materials. So if you can get the material data from MatWeb, then what we could do is actually add that into the system. So the answer is sort of a bit of yes and no, if you like. In Professional we can't, in Premium we can. I don't think the materials will import directly at the moment, but MatWeb may well start to release some data on SolidWorks Plastics. I've also got another question on where the mould flow data is stored. It's actually stored within a folder where the part file exists. So if your part file is stored in a folder, then a subfolder will be created within that folder based on the configuration name. So if you do want to look at alternatives, what you can do, it sort of functions on a configuration basis. So if you do want to make changes to a different configuration, you could do that, no problem at all. And then when you run the results will be stored in a separate folder where the part file is located. Okay, any more questions from anybody? Okay, so there's a question on how big this file is. The easiest thing to do, Colin, is to take a look actually. So within here we should have the folder. So the part itself is actually an imported part, and that's about 1.6 meg. If we actually look at the results data, I've got a couple here for configurations. We can see that folder's 14.6 megabytes. So, you know, it is a reasonable size, but it does have to store the mesh and all the plots as well. It's certainly not excessive, but that gives you a good idea of how big the files are. Okay, that looks like everybody. So thanks again for watching. Please do take a look at some of our other future webinars. If you do require any more information on SolidWorks Plastics, what's included, how much it costs, how the licensing works, please do give us a call on the phone number listed below, or have a chat with your account manager. That would be the best way to do it. Thanks again for watching, and we'll see you all again soon.